All right, calculus friends. At the end of class, we started talking about these differentiation rules. The power one, you already know. We're going to add to it product and quotient. And we're going to expand the power rule into talking about the constant multiple and then the sum difference. All right, so just a quick review, the limit definition of a derivative. We did this in class. And of course, you can see that it's a lot quicker to use the power rule. We still end up with the same derivative value. All right, some more derivative rules that we talked about. Anytime you take the derivative of a constant, that's going to be equal to 0. Some tricky ones to watch out for are e and pi. Pi is down here. We'll talk about this in just a second. But anytime you're taking the slope of the tangent line of a horizontal line, of course that horizontal line has a slope of 0. So the slope of the tangent line is 0. The derivative of a constant is always 0. Okay, a constant multiple, that's when you have a coefficient in front of the value that you're taking your derivative of. So if I have 6 times x cubed, my derivative is going to be 6 times the derivative of x cubed. And of course, that's going to give me 18x squared. If you have a value in a quotient, it's easier if you think of it like a coefficient. So when you go to take the derivative of this, y prime is going to be equal to 1/3 times 5 times x to the 4th. So then we can just multiply these values together and say that y prime is equal to 5/3 x to the 4th. All right, that's our constant multiple. Lastly, we're going to talk about the sum difference. And this one's pretty cool. When you are taking the derivative of a sum or a difference, it's just going to be the derivative of each of those different terms. So you take each term's derivative separately, and you just work your way down the line. So y prime is going to be equal to the derivative of this first term, which is going to be 4x, the derivative of this second term, which is going to be x to the first power. 1 times -5 is -5. X to the 0 is going to just, I'll write it down so you can see it. And then the derivative of my constant is equal to 0. So then that simplifies y prime is equal to 4x minus 5. And that's going to be our derivative value. Now this is a little bit of a messy one. So we want to try to decipher each of these individual parts so that we can take it. So let's just rewrite our original function. I've got 1/3 x to the 6th plus 8 times x to the 1/2 power minus 5 times x to the -1st power. This x down here in the denominator I can rewrite. And then of course plus 2 pi to the 5th. So now that I have each term written in exponential form, it's a lot easier for me to find my derivative value. I'm going to do the power rule for each one. 6 times 1/3 is 2x, drop 1 power. 1/2 times 8 is 4x, drop 1 power. -1 times -5 is positive 5x, drop 1 power. And then, of course, this is a constant value, so the derivative of a constant is going to be 0. So we'll go ahead and just put things where they belong. 2x to the 5th is fine, but we're going to say plus 4 times the square root of x. That's a negative, isn't it? Because 1/2 times 4, yeah. So that means that that square root is going to be in the denominator. And then this 5 stays in the numerator. My x squared drops, and my 0 goes away. So this is going to be my derivative value minus this mess here. Okay? All right, let's see what's in store for us on the other side. All right, so now we're going to talk about the product rule. And what the product rule is, if my function consists of two functions being multiplied together, and that f and g of x can represent anything. And you'll see that as we work our way down through the examples. Now our rule here is written very simply. It's going to be the derivative is equal to the derivative of the first function times the second function plus the first function times the derivative of the second function. So if you want to, we can write this out a little bit more clearly so that you can see. And what we're going to do is every time that we take the derivative, we're going to go ahead and put it in a box so we can tell the difference between when we're doing the derivative and when we're doing a value. You don't have to do this. A bunch of teachers do just because they think it makes it easier. So we're going to say the derivative of our first factor, of our first function, times our second function plus our first function times the derivative, I'm out of room, of our second. So we'll see that, and it's when both of our factors have a variable. If our factors don't have a variable, then I'm back to having that constant multiple. All right, let's check this out. Ready? Here we have our first function. We can call that our f, and then here we have our second function. We can call that our g, and we might want to rewrite that as x to the 1/2 power. All right. So when I want to find h prime, we can go ahead and say that h prime of x is going to be equal to, let's take the derivative of my first term. The derivative of my first term is going to be 6x squared. And then I'm going to take my second term, which is just x to the 1/2 power, and I'm going to add that to my first term, my first function, which is 2x cubed, and that's going to be multiplied by the derivative of my second function, which is 1/2 x to the negative 1/2. Now we're going to play around with different degrees of simplifying. Sometimes things work out to be simplified, and other times we're fine with leaving them as they are. If you have any doubts, you can always ask, but for the most part, we're going to leave things as is so that we can see that you put things in the right spot. Okay, let's take a look at this next one. My g of x is these two terms multiplied by each other. We'll make this one blue. We'll make this one green. So our derivative is going to be equal to the derivative of this first one, and it might be easier to rewrite it as that, because when I go to take the derivative of this, -1 comes out in front, and then I have my x to the 1 less power, and there's my derivative, times my second function, which is 2x squared minus 5, and that's going to be plus my first function, which is 1 over x plus 1, times the derivative of my second, which is going to be 4x. All right. So there you have those rules for figuring out the product. All right, so we're going to take a look at some fun table values, and in order to practice this, here we go. All right, the table below shows values of two differentiable functions, f and g, as well as their derivatives. Okay, so let's try to read this table. I've got my input values for x, and then I have my function, and then I have my derivative. So here's my function, and then here is going to be my derivative. You can see that by that prime. And then here I have my function of g, and then here I have my derivative. All right. Oh, how about the shadow? Let's see if we can make it so it's easier for you to see. My goodness. All right. So we want to find h of 2, so that'll be our input value. Let's go ahead and see. I've got my f of x function times my g of x. So my derivative of h is going to be equal to my derivative of my first. So as an input value of 2, I'm going to go over to the derivative, and that's a negative 2, times the value of the function at negative 2, which is negative 1, and then that's going to be plus the value of my function with an input of 2, which is 4, and then the value of my derivative, which is going to be 2. If it's easier, go ahead and review the fact that your product rule says it's the derivative of the first times the second plus the first times the derivative of the second. And you can see by my boxes, these are my derivative values, 2 and negative 2, and these are my function values, negative 1 and 4. Now all that's left is to do some simplifying. So I know that my derivative at 2 is going to be equal to positive 2 plus 8 for a value of 10. All right, let's go and look at this one for r. So for this one, we got to be careful with this 1/2, and we want to think about where that's going to impact us. We're talking about an input value of negative 5. So we have our g and our f function. Let's go ahead and write down what we're talking about. Our r prime is going to be the derivative of my first times my second function plus my first function times the derivative of my second. So r prime of x is going to be equal to, and we got to think about this 1/2. So that 1/2, when we take the derivative of f of x, the derivative of f of x with an input of 5 puts us here at 4. So I'm going to have 1/2 times 4. And my function for g at an input of negative 5 is going to be negative 2 plus my f of function, which is going to be 1/2 of 3, and then my derivative of my g is going to be equal to 5. So my r prime of x is going to be equal to 4 times negative 2, which is 8. 1/2 of that is negative 4. And then 5 times 3 is 15, and 1/2 of that is 15 halves, or 7.5. When I want to combine these terms, I'm going to go ahead and call for 8 halves. So my r prime of x is going to be equal to negative 7 halves. Oh, positive. More positives than negatives. So positive 7 halves. All right. Our next one, find the derivative. So what we have here is one function here and another function here. Go ahead and pause the video and check back in and see if our expressions match. All right, let's see how we did. Remember, if it's easier to think of x squared as x to the 1/2 power, then of course we can, that makes it easier to find the derivative. So if I'm finding the derivative of my power rule, I have the derivative of the first times the second, and there we have that, plus the first function times the derivative of the second. Now, some teachers are fine with you leaving it like this. If you feel like cleaning it up a little, that's fine too. All right, for number 3, for my g of x function, here's my derivative of the first times the second plus the first times the derivative of the second. Some teachers are fine with you leaving it as, or you can clean it up. All right, turn your page, and the next step is going to be our quotient rule. Now, the quotient rule looks very similar to the product rule, except you'll notice that we have a subtraction sign. So the derivative of the first times the second minus the first times the derivative of the second, and then the second squared. And keep in mind, when I talk about this second function, that's what's in our denominator. Now, don't laugh at this, but when I learned this, we sang a little Jeopardy theme song to it, and for that reason, we have our low first. So our low times the derivative of the high minus the high times the derivative of the low. And to the tune of Jeopardy, it goes low D, high minus high D, low, square the bottom, and away we go. So, if you feel like singing Jeopardy, any Jeopardy fans out there, the commutative property of multiplication says it doesn't matter what order we multiply these in. So, if singing the Jeopardy tune, low D high minus high D low, square the bottom, and away we go, if that helps you remember, rock on. I'm fine with that. All right, here we go. Ready? Here is our numerator, and here is our denominator. So when we go to find y prime, it's going to be low D high minus high D low, square the bottom, and away we go. And that's it. So some teachers will have you simplify, but for now, while we're getting used to using the rules, we'll go ahead and just plug it in and just have everything in the right place before we get too overwhelmed by the algebra. All right, g prime of x is equal to, are you ready? You going to sing with me? Low D high minus high D low, square the bottom, and away we go. So if you would like to go ahead and simplify that, rock on, you're welcome to. But for now, we just need to make sure that you have everything plugged in where it's supposed to be. Okay, we'll go back and we'll look at our table. Same kind of exercise as before. We have input values, and we have an f and a g function, and we have some different things going on. So we'll go ahead and we'll say find f prime of 2. So when we go ahead, we have a choice of whether we're going to go ahead and look at this function. Remember, here is the value of the function. F of 2 is 2. F prime of 2 is negative 2. G of 2 is equal to negative 1. G prime at 2 is equal to negative 2. So we'll go ahead and we'll say H prime at 2 is equal to, and we're going to first put our low, which is 3 G of 2 D high, which is F prime of 2 minus high F of 2 D low, which is going to be 3 G prime of 2, and that's our derivative. Square the bottom, and away we go. So 3G of 2 squared. So when we plug those values in, we get 3 times our value of G at 2, which is negative 1. So 3 times negative 1 times the value of f of x, f prime, which is going to be negative 2. And then minus f of 2 is 4 times the derivative, 3 times G prime of 2 is equal to 2. Square the bottom, and away we go. 3 times G of 2 is negative 1, and that's squared. So that looks to me like positive 6 minus 24 all over 9, which is going to be equal to negative 2. How'd you do? All right, you ready for this one? R prime. I'll do this in a different color pen. Probably going to run out of room. R prime of 2 is going to be equal to, let's do our low D high minus high D low. Okay? So our low is going to be one minus f of 2, and our D high is going to be G prime of 2 minus, and then we have our high, G of 2, D low, which is going to be the opposite of F prime of 2. And then we square the bottom, and away we go. So let's plug in our values. R of 2. So 1 minus f of 2 is 4. So 1 minus 4 times G prime of 2 is equal to 2 minus G of 2 is negative 1, and then we have 2. So f prime of 2 is negative 2, and we have that opposite of it. So positive 2. And then down bottom, we have 1 minus f of 2 is 4. 4 squared. So that's equal to, let's see, 2 times negative 3 times 2 minus negative 2 all over 1 minus 4 is negative 3. Negative 3 squared is positive 9. So we have negative 6 plus 2 over 9, which is equal to negative 4 ninths. All right, let's find the derivative. So we have this up high and this down low. Ready? The derivative of f of x is going to be low 2, and we'll go ahead and call this x to the 1/2 power, right? 2x to the 1/2 power, d high, let's use the chain or use our power rule, negative 3 x to the negative 4th. We're going to go ahead and rewrite this x as x to the 3/2 power. So the derivative is plus 7 times 3/2 is 21/2, and our x minus 1 is x to the 1/2 power, minus 2 times negative 4 is 8x. So here's our low, and here's our d high. So we'll put that inside of our boxes. Low d high minus, and then just the high. So we'll say x to the negative 3 plus 7 square root x cubed minus 4x squared. That's my high. Now I need the derivative of my low. So my 1/2 times 2 is 1. And then I'm left with x to the negative 1/2 power. So it's low d high minus high d low. Now it's time to do what? Square the bottom. And away we go. All right, that's it. So when you come in, we're going to play a game. And I'll give you Smarties if you sing the Jeopardy song. Hope you guys have a good weekend. Bye.